Hello and welcome to Level 1 Mechanics. This time we're going to look at distance time graphs. We're going to look at interpreting distance time graphs and using distance time graphs to calculate speed. I have to apologize for the audio because it seems to lag behind. I don't know how to solve the problem, so just ignore the little picture in the bottom corner if you like. Distance time graphs are set up like this. And on the y-axis we have the distance, and on the x-axis, the horizontal axis, we have time. Okay. Now I'm going to draw a few lines on this distance time graph and we'll have a look at it. Whenever you have a straight line, this tells you that you've got constant speed. Okay, the first part of this graph, we've got constant speed. There's a straight line. The second part of the graph, still a straight line, so there's a constant speed, but because it's horizontal, there's no change in distance, which means the object isn't moving, so it's stopped. The third part of the graph, we can see, is a straight line again, so there's constant speed, but we notice that the line is steeper than the first part of the distance time graph. This tells us that the speed is greater. Okay, so the steeper the line, the faster the object is moving. If we have a curved line, this tells us that speed is changing. And if you have a look at this curve on the graph here, it shows us that it's curving upwards, that actually the speed is increasing. You can see that the steepness of the line increases as we go along. So this object is accelerating. Okay, accelerating. Here we've got another curved line, sort of opposite of the previous curved line. This time we can see that the steepness decreases. Okay, it's very steep at the start here, and when we get over here, okay, it's not very steep. So this object is decelerating. Okay, we've got changing speed and the speed is decreasing, so we call this decelerating. Alright, calculating speed from a distance time graph. The gradient, sometimes people call this slope, of a distance time graph is the same as the speed of the object. Alright, gradient can be calculated using this formula, rise over run. Rise divided by run. Alright, here we have a distance time graph. Okay, we've got a constant speed because we've got a straight line, and it is moving. So this object starts out at distance of 2 meters and goes all the way up to 8. And it's taken it 6.5 seconds. Alright, gradient equals speed. Okay, you've got to remember that. And gradient equals rise over run. So to calculate rise over run, it's always a good idea to draw a triangle underneath your line. Okay, and if we look at that triangle, it doesn't matter where you place this triangle. We've put this one at the end of the line. We could have put it at the start as well. You still should get the same answer, no matter how or what position your triangle is in. But you will get more accurate results if you make the triangle as big as possible, because small triangles have a tendency to have a greater chance of being off. Alright, so there's our triangle, there's the rise. How much does this go up? Alright, while the run is how long it goes to the right. So with this triangle, you can see we've got a rise of 5. Okay, each of these gradations is 1, so we've got 1, 2, 3, 4, 5, and we've got a run of 4.5 because each of these marks, as they move to the right, is an increase of 0.5 seconds. So if we look at this, we start here, so this is 1, 2, 3, 4.5. All right. So now if we want to calculate the gradient, we take those numbers, put them in our formula. Rise over run. The rise is 5, the run is 4.5. Put it into our calculator, and it works out to be 1.11. We then can use this to tell us what the speed is. We just put some units at the end, meters per second. Okay, so speed is 1.11 meters per second. The reason we use meters per second is because we've got a distance that's in meters and a time in seconds. Okay, if the graph was kilometers for distance and for time we had hours, then our answer would be kilometers per hour. Let's take a look at another one just to practice up here. Distance time graph. Alright, gradient equals speed, gradient equals rise over run, so we draw a triangle underneath here, and notice I've drawn this triangle so this right at the start this time goes across and up. So our rise and run, rise is 6, run is 6.5. So we plug that in, gradient equals 6 divided by 6.5, and our answer is 0.92. And our speed then is 0.92 meters per second. And that's the end of this video, and that is how you do it.